Thank you so much. Thank you. And so my name is Mahsa. I'm here today to talk about, as he mentioned, recent developments in designing price-stable cryptocurrencies, also known as stablecoins. So a little bit about myself. I'm a PhD student and also blockchain engineer. I'm doing research at the Concordia Institute for Information System Security, Concordia University in Montreal. And I've also been a research intern at the Quebec's regulator, AMF, where I worked on decentralized exchanges and markets. And I've given quite a few talks on blockchain, Bitcoin, and cryptocurrencies in different venues, including last year's HackFest. And at the end, I'm mainly doing research on blockchain technology, financial technologies, and also decentralized finance. I've done some research on TLS and CA trust model, plus usable security. So here's what I'm here for today. It's our very recent research paper. It's a systemization of knowledge on stablecoins. And let's dive in. Let's start with the motivation of our work. So I'm not sure how many of you guys have traded cryptocurrencies in this room. So even if you have not, you know that all the cryptocurrencies are volatile. And by this volatility, I mean huge volatility, not anywhere near to fiat currencies. And I just realized that yesterday was Bitcoin's birthday. And I thought, why not? Let's have a kind of a chart here that shows how Bitcoin's price has been fluctuating in 9 years since it was born. So as you can see here, it is volatile and it's not stable. And again, to emphasize more on this volatility, we have a little chart here. It compares three main fiat currencies, including euro, Canadian dollar, and British pound. And we compared with Bitcoin from 2016 to 2019. And as you can see here, these three fiat currencies almost show a very stable value through these years. However, Bitcoin has been really fluctuating in these 3 years. And again, to show how significant this fluctuation is, just look at the Brexit here. This is when the Brexit happened in 2016 and when British pound lost its value. And it was huge, but in our little chart, it's a very little slope here when we compare it to Bitcoin's fluctuation. So the volatility we're talking about here is huge. And that was the motivation of our work and also all of those stablecoin projects that came into existence. Another reason for stablecoins to be around here is the three main properties of what we call money. And for anything, either currency or cryptocurrency, in order to be able to act as money, they have to meet three main requirements. The first one is it should be able to act as a medium of exchange. What it means is you should be able to use it in exchange for goods and services for others. Let's say Alice is only accepting something, either currency or cryptocurrency from Bob, when she's confident enough that there will be somebody out there who's willing to accept this money from Alice in exchange for other goods and services. Bitcoin is a good medium of exchange now because people are being able to trade Bitcoin for different stuff. The second property of money is it should be able to serve as a unit of account. What I mean is you should be able to price stuff in whatever you call money. And although things are being bought and sold in Bitcoin, they're not really being valued or priced in Bitcoin, and they're still being priced in US dollar. So Bitcoin is not really serving as a good unit of account. And at the end, we want money to be stable. It should preserve the stability value. And we know that Bitcoin, neither Bitcoin nor other cryptocurrencies are stable, and people are not willing to accept their salaries, for example, in a volatile cryptocurrency or currency. So what we thought is, what if we have a good cryptocurrency that is almost a good medium of exchange, let's say Bitcoin, and we can make it stable. And if it's continue to be stable for a while, maybe later in future, people can sort of use it as a unit of account. So that was the motivation behind our work, and also other stablecoin projects that came into existence. And that was why 2018 was called the year of the stablecoin. And we were overwhelmed by all those stablecoin projects that were born. And we know all of them. I only included some of them here: MakerDAO, Tether, USD, Nubits, and Basis Coin, which raised $133 million in venture capital, but they had to give it all back because they didn't feel they could comply with the regulation. And so we have a lot of stablecoin. There's a lot of blog posts, working papers, white papers, but if you even try to go and read these blog posts or white papers, you get overwhelmed. They're using a lot of jargons, financial terms, and they're not really clearly say the details of what is the mechanism they're using, how they create these stable coins. And as a researcher, we tried a lot, but every time we faced a lot of jargons like seniority shares, fiat back, collateralized back, and it wasn't really clear. So at the end, we were left with a question of how to design a stable coin in plain word. Like what are the mechanisms you can create stable coin with? And I'm happy to say that that's the reason why I'm here today. And this table that you can see here is the meat of our paper. So we were able to create some classification of mechanism by which you can create stablecoin. So don't get overwhelmed with this table, because I'll spend the rest of my talk explaining each and every category. But just to give you an idea how we created this table was, as I told you, it was a lot of stablecoin projects out there. So there wasn't really a source that gave us the list of all the projects. So what we did is we went to the CoinDesk, which is a very famous news source for cryptocurrencies and blockchain technology. And we searched for a price stablecoin, and stability. Doing so, we got 185 articles that were talking about these three keywords. And then we read and studied each and every of them. We got 25 projects that were alive, working, for which we could find some documentation in English that we could read. And using that, we were able to study the project and then create a table like this that explains what are the ways one can create a stable coin. And I have to point out the coins here are ranked based on their market cap from the CoinMarketCap website, which ranks the coins that are actively trading in decentralized exchanges. So yeah, as I've said, let's dive into the categories and see how we can create stablecoin. The main two categories are backed and intervention ones. And so we go back to the table at the end so that you can match the project you've maybe seen before, and you can really match them to the categories that I'm going to explain now. So the first category is the backed ones. The coin in this category, they try to match the stability of a second asset. And in fact, they cannot exist without their underlying asset. And the backed category itself, it falls into three categories. The first one is the one that are directly backed with the underlying asset, and they're not redeemable. The second one is the exact same thing. They're directly backed, but they are redeemable. And the last one, which is a little bit more challenging, is we call them indirectly backed. So the directly backed category, the coin in this category is like they're trying to directly back their value to an underlying asset. For example, for each stable coin that gets issued, they store one USD, let's say, in a physical location, let's say in a bank account or like a reserve. And as you may have realized, they need to be audited. Why? Because we have to make sure that they really have those underlying assets in that physical location that they're claiming. And this coin, they don't offer any redemption for their underlying asset. And I have to point out that this is really like the old idea of this, the coins in this group is the digital money, with the only difference that transactions are now decentralized, but still, issuance and redemption are being done off-chain. Why? Because you're storing that underlying asset from which the coins inherit the stability or volatility in a physical location. So we can't really do that on-chain. The second group is the exact same idea, with the only difference that they offer redemption. You can go back to the physical, to that bank account or whatever that is, and you can redeem your coin for the underlying asset. The third one is actually what was really interesting to us, and it was a little bit challenging to understand, because the coins in this category, they offer decentralization in everything. I mean, issuance, transactions, and redemptions. But because there is no notion of USD on a blockchain, such as Ethereum, what they do is they're using a cryptocurrency, such as Ether, and a currency such as US dollars, and they're getting an exchange rate between Ether and US dollar. And they're kind of indirectly backing their coin with US dollar through Ether. So to get more involved in this group, this is the very basic idea of this coin in indirectly backed category. So we can assume that they get some coin. I call them fairly volatile coin, just with respect to what they create after. So they create two positions. The first one is extremely volatile, and is extremely volatile, even more volatile than Ether. Ether itself is really volatile, but this one is extremely volatile. And then they create stable coins. So they're kind of pushing the volatility around to the other position so that they can get the stable coin out of it. We have an example here to make it more clear for you. Let's say in this system, Alice wants to create stablecoin. So what she has to do is she has to go on Ethereum and she creates a smart contract. At this point of time, the exchange rate between Ether and USD is 1. And because Ether is volatile, we don't want to be exposed to Ether's volatility. So Alice has to always put more than equivalent of 1 USD. And that's what we call over-collateralization ratio. And it's a fixed number in the system. The system decides for that. Here we can imagine it's 1.5. So in order to have a stable coin, Alice has to lock up 1.5 Ether. And by doing so, she creates two positions in line. The first one is the stable coin. That is 1 Ether equals to 1 USD. And the second one is whatever is remain. And she can then sell the stablecoin to Bob, and now Bob is holding stablecoin, which is 1 USD, and at this point of time, 1 Ether. But Ether's value can go up or down. Let's say Ether's value goes up. Now we can get 1 USD with a less amount of Ether. Let's say Ether is equal to 2 USD. So if at this point of time, Bob comes back to the smart contract and he wants to redeem his coin, he can still redeem it for 1 USD, but it's only 1.5 Ether. And then Alice would get more in compared with what she would get in the previous one. So she gets 1 Ether at this point. And the coin still has its stability because it's being traded at $1. Ether's value can go down as well. Let's say 1 Ether now equals to 75 USD. Now we need more Ether in the smart contract to be able to trade it at $1, trade the stablecoin at $1. So at this point, if Bob comes along and he wants to redeem his coin, he can still do that, but he would get 1.3 Ether, which is now 1 USD. The coin's still stable, and Alice gets a little bit less than what she would get in previous ones, 1.2 Ether. But this is the catastrophe that we could imagine. Let's say Ether's value goes extremely down. Let's say Ether now equals to 50 cents. So we need, in order to have 1 USD, we need 2 Ether now. But smart contract only contains 1.5 Ether. So at this point, if Bob comes along, he would redeem the coin, but he would only get 75 cents. The coin is not being traded at $1 anymore, and Alice doesn't get anything. So one of the projects that is indirectly backed is the MakerDAO, and they're using this mechanism to create their stablecoin DAI. And what they do to combat this situation is that they have some liquidation threshold, and they have watchers in Ethereum. Anybody can watch this smart contract. They go and they see if the Ether's exchange rate is hitting this threshold. And if it ever hits, they just liquidate the smart contract. And at this point, Bob and Alice gets whatever exists in the smart contract, and the stablecoin maintains its stability. So the other categories are the intervention ones. So these coins, unlike the backed ones, they're standalone currencies that they allow for intervention, either by human or algorithm, to maintain stability and reduce volatility. So as I've mentioned, they're not backed by any asset. Instead, they use intervention to make the stablecoin to remain stablecoin stable. And of course, they have various design decisions, such as when to intervene. And most of them are using the exchange rate between a fiat currency, such as US, to know when to intervene and what kind of an intervention. Some of them, they decrease or increase the supply of money. And how to decrease or increase. Some of them do it directly, some of them do it indirectly. And at the end, what are the participants in the system? Miners, holders, shareholders, whoever there is. So the intervention ones, they are either money supply adjustment or asset transfer. And these are the terms that we chose for these categories. I hope they would be descriptive. The first one is the money supply adjustment, which the coins in this category, they directly increase or reduce money supply. It's really easy. And they do it either based on algorithm or human discretion. And we studied them. They either give the new money to miners or all the holders, or they decide to remove money using a mining algorithm from the miners or all the holders. But this is the other group which was really interesting for us to study, which we call asset transfer. So it's the same ideology. They increase or decrease the supply of money, but they use an indirect way to do that, to bring money into circulation or withdraw it from the market. So I have an example here to show that what I mean by that. Let's say we have a system which is using this method, and stablecoin is supposed to be traded at $1. But at some point in time, the price goes above $1, and the system now wants to expand the supply so that it would bring the value of stablecoin back to $1. So what it does, it just creates the stablecoin, new stablecoins, and it gives it to people that are waiting in some positions in line. And then they would get the money, they would get the stablecoin, they would go back to the open market, start spending that stablecoin, and hopefully that would bring the value of stablecoin down back to $1. But I'm sure that there's a question in your mind now that how would people stand in this line? And that goes back to when the price of stablecoin comes below $1. So in this situation, what the system does is it auctions off these positions in the line, and it auctions it off to the highest bidder. So people will come, they're incentivized to bid, and because they bid using the stablecoin. So they're paying for this position using the stablecoin when the stablecoin is being traded less than $1. And then the payment will be removed from the market, it will be burned, and then that would hopefully bring the price of stablecoin back to $1. So this is really great motivation for them to do that, because later on, when the price of stablecoin would go more than $1, they would get their stablecoin back, and then they will benefit from the system. So yeah, that concludes my talk. There are a lot more details in our paper, which I couldn't talk about because of time, but I do encourage you to go. It's public, open to public access, and it's called Demystifying Stablecoin. You can find it on SSRN website. And also, you can ask me any questions after or even now. And this is my Twitter handler. And also, there's a GitHub repo where you can find all the details and text and stuff. Thank you so much.